Lesson 7-8, dividing a polynomial by a monomial. So we've done some multiplication, we've multiplied monomials by polynomials, and then we've multiplied polynomials. Now we're going to do some division, and dividing a polynomial by a monomial is basically the opposite of multiplying. We use the rules for dividing monomials. We just apply it to multiple terms as opposed to a single term. So when you look at a polynomial is a collection of monomials connected by addition and or subtraction. When we divide a polynomial by a monomial, we think of the polynomial as both the polynomial as individual monomials. So for example, if we have 8x to the third plus 4x squared minus 10x plus 16, this is our polynomial, and we divide it by the monomial 2x. What we want to do is we want to look at each term individually and divide them individually by that 2x. Okay, so 8 divided by 2 is 4. X to the third over x gives me x squared. 4 divided by 2 is 2. X squared over x is 1. We subtract the exponent, so 3 minus 1 is 2, 2 minus 1 is 1. 10 divided by 2 is 5, the x's cancel. And then 16 divided by 2 is 8, and we have that x left over, so that stays in the denominator. Now you don't have to write this out, you can individually divide each term, or you can write it out if you want to. That choice is up to you. So let's look at some, and I'm going to write them all out just so that you can follow the process. So I take each term of the polynomial and divide them individually by 3x. 9 divided by 3 is 3. 2 minus 1 is 1. 3 divided by 3 is 1. The x's cancel, and then 12 divided by 3 is 4, and my x remains in the denominator because nothing interacts with it. Here I have 11x to the fifth over x squared, 7x to the third over x squared, and 2x over x squared. Since there's no coefficient on the x squared, we keep all of the coefficients the same. 5 minus 3 is 2, 5 minus 2 is 3. 3 minus 2 is 1. And then here I have a 1 and a 2. The 2 minus 1, the bottom wins the tug of war, so we have 1 down here and a 2 in the numerator. Okay. In this example, 8 divided by 2 is 4. 3 minus 1 is 2. I have nothing to divide the 2 by, so the 2 remains in the denominator. 2 minus 1 is 1. 2x divided by 2x is just 1, and then this won't simplify at all, so I leave it exactly as it is. Sometimes the division is written as a division. So I have this is actually a monomial. Okay, well, it's good review. 12x to the fourth, y to the third, z squared w over 2xy squared. Now, remember with the multiple variables, we just divide each individual thing. So 12 divides by 2, the x to the fourth by x, y to the third by y squared, and the z and the w have nothing to divide by. 12 divided by 2 is 6. 4 minus 1 is 3. 3 minus 2 is 1, and then the z squared and the w remain the same. We'll apply that as well. I'll divide each of these individually by the 2ab squared. So I have 2a to the third b squared over 2ab squared minus 10ab to the third c over 2ab squared 2 divided by 2 is 1. 3 minus 1 gives me 2. 2 minus 2, the b's cancel. 10 divided by 2 is 5. The a's are going to cancel. 3 minus 2 is 1, and the c has nothing to interact with, so it just stays the same. Again, divide each term of the polynomial by the monomial. So 2r squared s to the third t over s squared t plus 2s to the third t squared over s squared t plus r s to the fourth t to the third over s squared t. The r has nothing to interact with, so it stays the same. 3 minus 2 is 1. The t's cancel. 3 minus 2 is 1. 2 minus 1 is 1. Again, the r has nothing to interact with. 4 minus 2 is 2. 3 minus 1 is 2. So this is how you'll divide polynomials by monomials.